Alrighty, in this video we are going to start off by getting ourselves ready to put together a service layer. And it's going to require a little bit up front, but you guys are going to see that that little bit of effort up front is really going to clean up most of our API calls. In fact, the majority of our live API calls are going to be one line of code for the retrofit service interface and one line of code in the respective service class. But that's going to require us to put together a couple classes, and that's what we're going to do in this video. I'll also show you guys this, the Eura Playground. So if you head on over to eura-playground.3dbuzz.com, you can generate a sandbox for you guys to play around with. So this playground is going to have all of the live API calls available to you. It's fully functional and it's all isolated. So you can go ahead, jump over to this site, scroll down to the bottom, and you can generate a sandbox. However, I will ask that you do read the terms and conditions and privacy sections before you do so. All right, so let's go ahead and do that. I'm going to go ahead and generate this. And then I'm going to go ahead and hit generate. And what that's going to do is it's going to create me a token that I can use. And I'm going to attach this token to each one of my requests made out to this API. And that's how it's going to identify it as me and not somebody else. So let's just go ahead and give it a second to do that. Occasionally, a couple requests to this service may take a little bit of time. That's because it is an ASP.NET application, and it will spool down if it's not used after a while. But if once it spools back up, it'll run just fine. Anyway, here is my API token. So I will be using this here in a second. So what I'm going to do is I'm going to take this window and I'm going to push it off over to the side. And then when I need it, I'm just going to copy and paste it in. Okay, so let's go ahead and get started. What I'm going to do first is I'm going to jump into my infrastructure URL application. And inside of this, I'm going to create a couple constants. And up here at the top that are going to be used to identify the service endpoint and to identify my token. So I'm going to create a public static final URI, and I'm going to import class on that. And this is going to be API_endpoint, and it's going to be equal to URI.parse, and this is going to be HTTP eura-playground.3dbuzz.com. So that is the endpoint. Then I'm going to do a public static final string student_token, and I'm going to assign it to that token that I just generated. So let's go ahead and take that and paste it in there. So with the API endpoint student token, we have the 2 bits of information that we need to hit the API with. So moving on from there, what I'm going to do is I'm going to implement 2 classes in my infrastructure. And they're going to be wrappers around the retrofit callback. So this is how we're going to handle errors in a very consistent way. So instead of, as you saw before, how on async methods you have that callback that has a success and failure, I'm going to consolidate those 2 methods into one single method. And unfortunately, this wasn't really the way retrofit was designed to be used per se, but it really, really cleans up the code. And it's a little hacky, but it's going to get better. This type of code is going to get easier to write as retrofit matures a little bit. I saw some new things on the new version that might be coming out in some time that'll make this sort of thing a little easier. But for now, we have to do a little bit of work. So what I'm going to do is I'm going to go on my infrastructure package, add a new class, and I'm going to create a retrofit callback. This will be a generic type. So up here, I'm going to add brackets, T extends service response, and then it's going to implement callback from retrofit. So make sure you select the right package because there's a million things called callback from retrofit, and it's going to pass in T as the generic parameter. Now, of course, this is going to necessitate that we implement these members. So I'll go ahead and hit Alt-Enter, Enter, and Enter. So we have onSuccess and our onError methods. Unfortunately, actually, they didn't generate properly. So let's see, what callback? We did get callback. We did not get the generic callback, it seems. Ah, I see what happened. I imported the Picasso callback. I hope you guys noticed that. Go ahead and nuke that. I'm going to hit Control Space here, and I'm going to find the retrofit callback. Where are you? Or at the end of the day, we can always just import it manually. Oh, because we haven't imported it into the project. I'll leave this in the video too, just to really stress that we have to make sure our dependencies are up to date. So I'm going to temporarily remove this implements callback so that our code compiles. I'm going to come down to Gradle scripts. I'm going to come down to build.gradle, and I'm just going to go to Retrofit site. If you just Google Retrofit, the first result is their site. And I'm going to scroll all the way to the bottom like we did in the last video, and I'm going to pull in Retrofit. I'm also going to scroll down and pull in the next group. So I'm also going to pull down the HTTP, because we're going to use that to integrate into Retrofit to do some cool things with authentication. So let's hit sync now. Basically, HTTP is kind of the request driver of Retrofit, and by importing it, we can manipulate it and change how it performs its request pipeline. All right, now that we've done that and we've synced the Gradle project, now I can say implements callback, and I can select the one from Retrofit, and I can make it a generic, pass in the generic argument. Then I'll hit Alt-Enter, and we have our success and failures. All right, next up what I'm going to do is I'm going to create a tag at the top, because we're going to do some logging in this. I'm going to say public or private static final string tag equals retrofit callback. Then I'm going to create a protected final class of T result type, and then I'm going to create a public constructor that basically just takes in result type. So I'm going to hit Alt Insert Inner. So the result type, just like how it's basically this, it's the thing that comes from Retrofit itself, and this is going to be used in our Retrofit callback in order to instantiate responses when a failure happens. So let me show you what I mean by that. So what I'm going to do here is I'm going to make this an abstract class. I'm going to say public abstract class, and then I'm going to, right underneath the constructor, create a protected abstract void on response of TT. Then for success, I'm simply going to do on response of T. The success is the simplest possible implementation here. We get a success. That means the object that was returned does implement the thing that we made a generic parameter of, and everything is happy. But the failure is where things get a little complicated. There's a bunch of different error conditions. My goal is to instantiate a service response for any condition, whether it failed because of an unknown network issue, whether it failed because of a 401 bad request, a validation issue, a 404, doesn't matter. Anything, I want to go into the onResponse method. And then I want to fill out the service response class with the errors that they may have, so that the code that says if response did not succeed, do this, otherwise do that, will work properly. So to do that, I'm going to say I'm going to start off with a log.e, and I'm going to say error sending request with plus result type get name response, and then error. This is we have to pass in our tag. This error, retrofit error, is a throwable or a runtime exception, which means that I can pass it into my log.e and it'll get printed out. Next up, I need to create my own service response error. So I'm going to say service response error result, and I'm going to say try error result equals result type dot new instance catch exception e. And basically here, I'm just going to throw a new runtime exception. This should never happen. Runtime exception, error creating result type get name. Does it? Or it doesn't really matter. I'll just pass in the E right there. All right, so now I'm going to say if error.getKind equals retrofit error.kind, and then I'm going to do .network. Then I'm going to say error result .set critical error unable to connect to your servers. So this is a catch-all for any network error. And then I'm going to say on response cast to T error result, and then I'm going to say return. Next up, I'm going to say if error.getSuccessType equals null, then I'm going to say error result dot set critical error unknown error please try again. And then I'm going to say on response, cast a T, error result, and then I'm going to say return. Then I'm going to open up a try block, and in the try block I'm going to say if error.getBody instance of service request or service response, then service response dot or result equals cast to service response error. And then inside of this, I'll say if result.did succeed, then result.set critical error unknown error. Please try again. And we will simply do on response, or whoops, outside of that, we'll do on response cast to T result. Otherwise, I'm going to throw a new runtime exception with result class, result type, get name, does not extend service response. And then after all that, I'll throw in a catch down here, exception E, which will do a log.e tag unknown error E, error result dot set critical error unknown error. Please try again. And then on response cast to T error result. Let's go ahead and fix this right here. What's going on there? I meant error.getBody, didn't I? And I should probably spell please and try properly, as well as that. Okay, so what's going on here? Basically, I worked with Retrofit for quite a while, and I caught all the different weird error scenarios that I could in order to make it behave the way I wanted to. So, for example, sometimes the get success type will be null under certain circumstances. Sometimes the error.getBody will not be an instance of a service response. And that's usually because you messed up and didn't implement service, or it didn't inherit from service response when you created your result type. And then also there are unknown errors that happen at any stage in the point in which we want to set things up. The path that's most likely going to be invoked is this right here. This is the path that, let's say the server returned a 401 bad request specifying that there's a validation error. And what I want to do here is, if there's a validation error, my property errors and my operation errors are going to be populated. And since they're going to be populated, then I can just pass that along to the user. However, if there was an error, but those weren't populated, so result.did succeed was set to true, then set a critical error, indicating that something is very wrong. Now, the last thing I want to do is I want to suppress this warning here. So I'm going to say, whoops, not try to generify. I'm going to Alt-enter that, move this over here, and I'm going to say suppress all from method, which will suppress all these unchecked errors. All right, that's our retrofit callback. Now, there's another retrofit callback that I want to write, and that's going to be the retrofit callback post. Now, the retrofit callback post is basically all the retrofit callback is going to do, except for, in addition to all this stuff, it's going to post a response to the bus. So I'm going to create a new Java class and say retrofit callback post, and then I'm going to say T extends service response, and this extends retrofit callback of T, and this will necessitate, of course, that I implement the onResponse method. Then I'm going to go ahead and I'm going to do a private static final string tag equals retrofit callback post. And then I'm going to say private final bus. And then I'm going to create a constructor that takes in a bus and also a result type. So that all got generated for me really easily. All I did was alt insert inner. Now let's implement the on response. I'm going to say if t equals null, which sometimes can happen, I'm going to say try t equals result type new instance, catch exception e, log e tag could not create blank result object e. And then at the end of onResponse, I'm going to say bus.post t. And that's it. So here's the thing that with all this stuff working together, it's going to work with all of the service calls that we already have, because all of our service results implement or inherit from service response, so they can have all the additional property and operation errors. I am going to go into service response, and I'm going to do one change in here. So jumping into service response under my infrastructure package, I am going to give my operation error a serialized name, and same with my property errors. The problem with this is the way that I'm going to have GSON do my deserialization, it's not going to pick up on either of these private fields unless I give them a serialized name with the proper casing. I'm actually going to have it do the opposite of what it did in the last video, because most of my API calls are going to return capital properties except for the envelope itself. Okay, so yep. So that is our awesome retrofit callback and retrofit callback post. So yeah, let's go ahead and move on into our live services. So I'm going to open up my build variants folder here. And what I'm going to do is I'm going to come down here and I'm going to switch from in-memory debug to live debug. So now what I have are all of my live services, including my live module, which currently doesn't do anything. So what I'm going to do here is let's go ahead and work on the module. Now, in order to implement the module, I do need to go ahead and stub out my web service. So I'm going to right-click my live folder, new, Java class, and I'm going to call this Yora web service, and I'm going to have it be an interface, and then I'll hit OK, and I'll clear out that comment. Now, I'm not going to do anything else in the Yora web service. We are going to be working on that later. But now that I have this interface written, I can write my module, because my module is going to be responsible for pretty much building my retrofit service, as well as registering all my other things. Okay, so the first thing I want to do here is I want to do just some boilerplate stuff. I'm going to be basically working bottom up in this class. I'm going to do all the stuff on the bottom first, and then work my way up to the top, because that's how the code kind of depends on itself. The first thing I'm going to do is I'm going to create a new JSON serializer or deserializer that will support the format of dates that are going to be returned by the Yora playground. So to do that, I'm going to write a private static final string array of date formats, which will be a new string array, and I'm going to initialize it. We're going to initialize it to YYY, YMMDD, T, HH, SS, Z. So this date format is a pretty standard date format that includes your year, your month, your day, and your time zone, as well as your offset there. So your time right there, then your time zone right there. So I'm going to go ahead and I'm going to copy and paste this 1, 2, 3, 4 times. And the reason I'm doing this is each date's format that we're going to support is going to be less restrictive than the one before it. So the next one, I'm going to go ahead and I'm going to knock off that Z at the end, knock off that time zone. The next one, I'm going to knock off the seconds entirely and just do MMZ. So we'll do MM time zone. And then the next one, we'll just do MM. And then after that, we'll do no time. So we'll just do YYYMMDD. So this array of formats are what's going to be attempted to be parsed by the application. All right, so now I have to create a JSON deserializer. And this is something that comes from the serialization library that Retrofit uses. So I'm going to do a private static class date deserializer. So DESRIALIZER, I hate that word, implements JSON deserializer, which you'll notice comes from com Google JSON, or JSON, GSON. And I'm going to do the of type calendar. So this date deserializer will deserialize calendars, which is what I want. Let's go ahead and hit Alt-Enter to implement its method, its deserialize method. And for here, I'm going to say for string format in date formats. I'm going to say simple date format, date format equals new simple date format, and then locale. And here I'm doing locale.us. And then after that, we're going to say date format dot set time zone, and I'm going to set the time zone to timezone.getDefault. So that'll be the default time zone for this conversion. Then I'll say date equals date format dot parse JSON element, date format dot parse JSON element, which is just JSON, dot get as string, and then I'm going to say calendar, calendar equals new Gregorian calendar, and then after that I'm going to do calendar dot set time in millis, and I'm going to do date dot get time plus time zone dot get default dot get offset 0. And then I'm going to go ahead and say return calendar. And then I'm actually going to wrap all this stuff in this for loop around a try block, because if the parsing fails, I want it to move on to the next format to try to parse it. So I'll say catch parse exception ignored. Then at the end of this, if it gets through this entire for loop and doesn't get a single proper parse, I'm going to throw a new JSON parse exception. Cannot parse date plus JSON.getAsString plus quote. All right, moving up. Now let's go ahead and write an interceptor. Now an interceptor is something that comes from OKHTTP, and we're going to use this to send our auth token with every single request. So what I'm going to do is I'm going to create a private static class auth interceptor that implements interceptor, which unfortunately doesn't exist yet. And the reason it doesn't exist is because I pulled down the wrong version of OKHTTP. Let's nuke that, and let's jump back into our build.gradle. Unfortunately, it seems that the Retrofit's documentation is out of date with which version of OKHTTP they have. So I'm going to change the version of OKHTTP to 2.2.0 on both the URL connection and the OKHTTP itself. So let's go ahead and do that and hit sync now, and have Gradle come down and pull down our dependencies for us. Now we have that done. Let's come back to module, and now let's implement interceptor for reals this time, which does come up, and I can hit enter. And now I'm going to hit alt enter, enter, enter. So the auth interceptor will, not surprisingly, it's going to be part of the OKHTTP request pipeline, and it's going to get an opportunity to modify any OKHTTP request that happens. So he's going to accept an auth, and he's simply going to say this.auth equals auth, and then of course we'll go ahead and alt enter this to create this field, so we'll have a private final auth. Then what I'm going to do, in the intercept method, I'm going to say request, and the request I want to pull up is the com square up OKHTTP. Request equals chain.request. So we're telling the chain to continue on its own way to implement the request, or to create the request for us. Then I'm going to modify the request if we have an auth token. So if auth.hasAuth token, then request equals request.newBuilder.addHeader authorization bearer, for the value we're passing in bearer plus auth.getAuth token, and then at the end we're going to do .build. So we're creating a new request that has a new header right here if we have an auth token. Then I'm going to do response equals chain.proceed request. So we'll move along with the rest of the interceptors and finally make the actual call. And then I'm going to say if response.is successful, then I'm going to return the response. If the response is not successful, so if response.code equals 401 and auth.hasAuth token, I'm going to say auth.setAuth token null and leave it at that. And then I'm going to return response. So basically what we're doing is we're saying that if we have an auth token, send it along with the request, so that the API knows that we're logged in as a user. Otherwise, if the response is not successful and we return an unauthorized, then let's go ahead and nuke our auth token, because obviously our auth token has expired or is no longer correct. All right, now we have one more big method to write. Well, it's not that big, but it's going to be private static Euro web service create web service, and it's going to take in Eura application. First thing I'm going to do is I'm going to create my own GSON, because remember, we're customizing how the GSON does its parsing and unparsing, serialization and deserialization. So GSON equals new GSON builder. And then I'm going to say set date format. So this is the format it's going to serialize to. And we're going to do YYYY-MM-DD-T for time. So that's a literal T. Hour, minute, second, time zone. And then I'm going to say register type adapter of calendar.class new date deserializer. Then I'm going to say set field naming policy. Now this is where it changes how the field naming policy works. So how does it translate between the fields that are returned in the data and the fields in our strongly typed objects? In this case, I'm going to use field naming policy, and I'm going to pass in .upper camel case, because that'll be compatible with how I wrote the API, and then .create. Next up, we need to create the OK HTTP client. So I'm going to say OK HTTP client equals new OK HTTP client, and then I'm going to go ahead and say interceptors.add new auth interceptor, and then we're going to pass in application.getAuth as its parameter, and then I'm going to create the REST adapter. So this is the part that we did in the last video. So I'm going to say REST adapter equals new REST adapter dot builder, and then I'm going to pass in set endpoint to your application dot endpoint, API endpoint. Set converter equals new GSON converter, passing in our JSON, that name bugs me so much. Then set client, and we'll set the client to a new OK client and pass in our client, and then set request interceptor, new request interceptor. Now we could have done this part inside of my interceptor, but I wanted to show you another way you can do interceptors. Another way you can do interceptors, if you just want to add a header without any additional logic, you can register a request interceptor with Retrofit itself. And what I'm going to do here is I'm going to say request.add. Now this is important. If you don't add this header, then it's not going to work with your student token. So x.add x-student your application student token. Then I'm going to do .build. Then finally, I'm going to do Euro web service equals adapter.create Euro web service.class. And then I'm going to say return web service. We could have just inlined that. I don't know why I did it like that. And then finally, I get an error on this set endpoint because I need to do api.endpoint.toString because it doesn't accept a URI, it wants a string. All right, so it's a lot of code, but it's mostly straightforward. First thing we do is we create our serializer. The next thing we do is we create our HTTP client. And the final thing we do is we wire them all up together with Retrofit. So we set our endpoint, we set our converter, we set our client, we add a header to every request, and then we build it. After that, we create our Euro web service. Alrighty. So now what I want to do is I want to stub out our services real fast. I'm not going to be writing all their methods. I just want to get the classes done so I don't forget to register them with the bus. And then we can finish the register method. And after that, we'll be ready to start knocking off each API endpoint. So I'm going to right click. I'm going to go up to Java live. I'm going to right click this folder, this live folder that only applies to this build variant. And I'm going to say base live service. Now, base live service is going to have a couple of convenience fields. It's going to have a protected final bus, a protected final Euro web service, or we can just do API. I'll call it API instead. And then protected final Euro application. And then I'll hit Alt Insert Inner, and I'll throw in a constructor that has all these. I'll make the constructor protected, and I'll make the class abstract, because this class isn't really designed to be instantiated directly. So that's our base live service. So now what I want to do is I want to create my live account, live contact, and live message services. So let's right-click this, go to New Java Class. We'll do our live account service. He is simply going to inherit from base live service. Actually, no, I was right. Well, actually, no. I want to quickly modify the constructor here. I don't need to take the bus in as a parameter. I can clear that out, and then I can say this.bus equals application.getBus. All right, now after I did that, I can come back to live account service, put my keyboard cursor on the squigglies, hit Alt-Enter, Enter, and it'll generate me that constructor. I want this constructor, however, to be public. Then let's create a new class for our live contacts service. He will also inherit from base live service, and we'll just generate his constructor and make it public. And then let's do the same thing for our live messages service. And he will inherit from base live service. Hit Alt-Enter, Enter. Make it public. All right, so again, just class stubs. They don't do anything interesting. Now let's jump into our module and actually instantiate them. Or, well, I think I actually forgot another thing to do in the base live service. See, I was like, oh, I really want to do this right now because I don't want to forget in the future. Well, I managed to forget. Make sure that you go ahead and say bus.register this. Otherwise, nothing is going to work. So make sure that you set that. If you don't, it's all broken and the world will end. All right, so if you did that, let's jump back into module, and then in our register method, we can go ahead and instantiate our services. First thing I'm going to do is get my web service. So I'm going to say web service API equals create web service, passing in application. Then I'm going to say new live account service, passing in my application and API. New live contact service, application API. New live message service, application API. And that's it. Let's go ahead and I'm just going to hit run, even though it's not going to work or really do anything. I just want to make sure I don't have any compiler errors that I might have accidentally introduced. But once... Oh, I do. Oh, I managed to get a import for an in-memory service here. That's weird. I can just remove that. That's innocuous. Good thing I did that build right there. Give it a sec to build. Give it a couple more seconds to build. And again, at any time in this series, you can definitely go and check out the GitHub repo. So I know a lot of this code it might seem a little obnoxious to write, and it is, but it's what you do. Okay, why is it still not building, but I don't think it gave me an error. Let's try this one more time. Just one more time. I'll leave this up here on the screen if you guys... Okay. What error are we getting? Class name, your web service does not... What? I'll be right back. Well, I'm back. That was weird. All I did was I added a temporary method to this interface, and then I compiled and it worked, and then I removed the temporary method, and then I compiled, and it still worked. I think that was actually a bug in Android itself, or the Android compiler itself. But either way, I think we're good. So I guess in the next video, we'll start actually implementing these guys. Once we get all three of these guys implemented, we will have a live working application. So I guess we'll see you guys then.